All right, so Unit 4 is all about quadratics. So it's very similar to some of the stuff you've done in grade 10, but there are a few changes. And this first lesson is the first major difference. So the first thing we're going to talk about are operations with radicals. So to start, let's go over the definition of a radical. So what is a radical? So basically a square root, or a cube root, or any root is a radical. So that funny, what we would always kind of call a square root sign, is actually called the radical symbol. And there are actually two types of radicals, and up until this point, we've only ever used one, but we have entire radicals and mixed radicals. So I can write them like this, the square root of 27, or I can write them like this, 3 times the square root of 3. And how I would word that if I was talking about it is I would say 3 root 3. That's how you would say that in normal words. So one thing that we really need to start doing now is we always need to simplify our expressions into a mixed radical. If you haven't done that, you will lose part of a mark because your answer is not fully simplified. So let's do a few examples and I'll show you how this works. So when we convert entire radicals into mixed radicals, what we're trying to do is basically put it into lowest terms. So the first thing you want to do is you want to think of the largest perfect square that divides into the radical. Sorry, that should say radical. There's a little bit of a typo there. So some examples of perfect squares are 4, 9, 16, anything that if I were to square root them, I would get a nice whole number. Then I'm going to split the radical into the product of two radicals, and I'll show you what I mean by this with an example in a moment. And then we'll simplify the one that contains the perfect square. So I think the easiest way to do this is to go through some examples. So the first example we have is root 8. So I want to think of a perfect square, so 4, 9, 16, 25, etc., that goes into 8. So the first one I'm going to think of is 4. So this is the same thing as 4 times 2. So because 8 is 4 times 2, I can do root 4 multiplied by root 2, like this. And now I can simplify root 4. So that is the same as 2 root 2. And if you put root 8 in your calculator, you would get the same thing as if you put 2 root 2 in your calculator. They actually mean the exact same thing. So this is our simplified version. That is what you need to have on all of your answers moving forward. Let's try another one. So the second example is root 72. So I want to think if root 72 is divisible by any of my perfect squares. So I start thinking of 4, 9, 16, 25, and 72 is divisible by 9. So I'm going to do root 9 times root 8 because 72 is 9 times 8. Now I can simplify that root 9, so square root of 9 is 3. And then I want to keep going. So I can still simplify root 8. So just like we did in example A, root 8 is root 4 times root 2. And root 4 is just 2, so I'm left with 6 root 2. And that is our final answer. Let's do another one because it does help to keep doing examples with this. So our next one is 2 root 147. So we want to start by thinking of the factors of 147 and thinking if I can divide that nicely by any of my perfect squares. So again, my perfect squares, 4, 9, 16, 25, 36, 49, 64. And 147 can be divided into root 49, root 3. And some of these you might just have to keep trying. So you can go through all of your perfect squares, have them ready to go, and then try dividing 147 by all of them. So root 49 is 7. So I can multiply that by that 2, and I'll have 14 root 3. And that would be my final answer. Any questions so far about this stuff? Okay, let's try multiplying some radicals, which we're basically already doing here, so it kind of follows and makes sense. So when I'm multiplying radicals, if I have root a times root b, that is just the square root of a times b. Similarly, if I have a root b times c root d, that's the same as ac multiplied by root bd. So I can take those coefficients out in front and multiply them, and then I can multiply the radicals as well. So let's try a few of these. So our first one here, we have root 6 times root 3. So because they're both under the square root and they're being multiplied, I now have root 6 times 3 is 18. So that would be my final answer. Next, I have 9 root 2 times 4 root 7. So what I'm going to do is I'm going to multiply those coefficients first. Hi, Ethan, you can start typing your question in the chat. So 9 times 4 is 36, and then we'll have root 14 like this. We'll just wait for this question to come in, and then we'll continue. Yep, so we could absolutely take this and simplify it a little bit further. The reason that I didn't was just because we were focusing on the multiplication, but we certainly could continue this into 9 times 2 and have 3 root 2. We could absolutely do that too. I was just focusing on the multiplication, but that is really as simple as it gets. Okay, now our next one here, we have negative 4 root 6 times 2 root 6. So now we're going to have negative 8 root 36. Now root 36 works out very nice. So we have negative 8 times 6. So one thing it's important to notice here is when I multiply root 6 times root 6, I end up with just 6. So that's something that's important to note. And then I just end up with negative 48. That's my final answer. Okay, so again, the important thing to note here is that root 6 times root 6 just equals 6. So if we ever get that situation, it always works out that way, which is really handy. Okay, let's now go through adding and subtracting radicals. So, like radicals, this word, our radicals have the same number under the radical symbol. So, kind of like terms. So you know when you've done your distribution and then you collect all the things that have x's or all of the x squareds? Similarly, you can do that with radicals. So for example, here I have 2 root 3's and 1 root 3. So in total, I have 3 root 3's like that. So we're going to treat it just like collecting like terms normally. Next, I have root 8 plus root 18. So the first thing we're going to do is we're going to go through and simplify this, and then we'll see if there's anything we can add. So the first thing we do to simplify is we think if we can divide 8 by any of our perfect squares, and we can divide it by 4. So we'll have 4 and 2. And then 18, we think if we can divide it by any of our perfect squares, and we'll have 9 and 2, like this. So that will give us 2 root 2 plus 3 root 2. And now we have like radicals. So now we can combine these. So that will give us, we have 2 root 2's plus 3 additional root 2's. So in total, we have 5 root 2's. So if there's any questions, feel free to type them so I can get to them. So for the third, oh, yep, Dimitri, you can type your question in the chat. So that's actually a really good question. Let's address that. So for example, I'll put in a different color so we know that it's different. So if I had something like this, 3 root 7 plus 2 root, I don't know, 5. These cannot be combined in any way. That's as simple as it can get. It's very similar to if I had this, 3x squared plus 2x. These two things are not like terms, so we can't combine them. Similarly, these two are not like terms, so I can't combine them. It's very much the same idea. But that's a really good question, so I'm really glad you asked that. Okay, so let's go on to the other one. So for this one, we have root 20 plus root 45. So again, our first step is to think about our perfect squares and which ones can go into 20. So in this case, I'll have root 4 and root 5 because 4 times 5 equals 20. And then for 45, we're going to have 9 and 5. So again, all I'm doing is I'm looking at that number 45 and I'm thinking, is it divisible by 4, 9, 16, 25, and go through all of those. Feel free to also find all your perfect squares and maybe write them at the top of your page if you don't know them off the top of your head. We'll do enough of these that you'll start to know them really well. So now we have like radicals because they both have a root 5. So that means that we can simplify them and then combine them. So that will give us 5 root 5 like that. Okay, so we have two more quick examples actually. So our next one is expanding and simplifying. So we're basically just going to be taking skills that we already had and adding in some radicals here, just so you can see how it doesn't really change too much. All of our old rules still apply. So for expanding and simplifying, we're going to simplify this radical. So to start, because we have a binomial, so a bracket with 2 terms, multiplied by another binomial, we have to use FOIL. Please make sure to draw your arrows. I know it seems really silly, but when people draw the arrows, they have far less opportunities for errors. When people don't draw the arrows, that's when they accidentally miss something, and it's really easy to do. So now let's go through all of our terms. So we start by doing 3 times 2, which is 6. 3 times root 24. So we're just going to say 3 root 24, like this. And then we have negative root 6 plus 2, times 2. So that will give us negative 2 root 6, like this. And then we have negative root 6 times root 24. So that gives us negative root 6 root 24. Just like that. So now what we're going to do is we're going to simplify these and see if there's anything we can start combining. So 6 is as simple as it gets, so we just leave that. Let's see if we can break down this root 24 into two different numbers, one of which being a perfect square. So in this case, that would be root 4 times root 6, because 4 and 6 multiply to 24. And then we have minus 2 root 6. Unfortunately, not much we can do with that root 6. And then we have root 6 times root 24. Sorry, somebody just entered the thing. I thought it was a message on the chat. So now I'm going to do the same thing with that root 24. So we have root 4 times root 6, like this. And now let's simplify that. 6. Root 4 is just 2. So that will give me 6 root 6 because I just did 2 times 3. Minus 2 root 6. And now root 6 times root 6 is going to give me root 36. So let's go through, and I'm going to do an extra intermediate step here just so you can see it, but you don't need to do this step. So now I have negative 2. So the 2 comes from that root 4, and then root 36. Now root 36 is just 6. So I can rewrite this as negative 2 times 6, which is going to be minus 12, like this. So anytime you have root 6 times root 6, you can just write 6. I just wanted to make sure I went through all of the steps so that everyone knows exactly where it came from, but you don't have to write that intermediate step if it's clear to you. Okay, so now let's collect some like radicals. So these two are like radicals, and these two are like terms as well. So that will give us 4 root 6 minus 6, like that. And that is our final answer. Yes, Alan, feel free to type your question into the chat. So your calculator might be able to go to the final step. It is really important that you know how to do this in case you are taking grade 12 math. Also, here's kind of how it marks from like a marking perspective. If I were to mark this, you would get a mark here for doing the distribution. You would get a mark here for switching everything and simplifying, and then you would get a mark here for collecting like terms. So I would probably make this out of 3 marks, is probably what I would do. If you use your calculator and go from right here down to right here, the only mark you've shown me is this one. So what would happen in that case is you would just get a 1 out of 3. And the reason for that is because I need to ensure you know how to do it. It's a part of the course and the curriculum to know how to do all the steps. If this was a in-class situation, we would have a quiz on this without calculators. So, but I mean, you have your calculator with you, so when you're doing the homework, definitely check your answers because then you know if you got it right or not. But that's why I need to see all the steps. Okay, so our last rule with these is rationalize the denominator. So that sounds like a really big word, but it's actually not that intense. So our last rule with our radicals is we cannot have a radical in the denominator ever. That is really bad form and you're not allowed to do that. So we're going to get rid of it. And here's your process for how to do that. So here I have 1 over root 8. I can't have root 8 in the denominator. That is not okay. So what I'm going to do is I multiply the bottom by root 8, and I multiply the top by root 8, like this. So that will give me root 8 on the top. And remember that root 8 times root 8 is just 8. So it gives me this. Now, what we can do is to continue making this nice and simple, is we can simplify that numerator there. So root 8 goes to root 4, root 2, all over 8. And you'll notice you start seeing certain numbers like root 8, and you start to see a pattern and remember what they're equal to. So that will give me 2 root 2 all over 8. And now let's go and simplify that fraction. So that will equal, don't mind my bad form, I'm running out of space to continue to go downward. 2 divided by 8, I'm just going to reduce that fraction. So that would be a quarter. So I have root 2 over 4, like that. So that would be my final answer. So these two are the same thing, but I need it in that final form. Yes, Destin, you can type your question into the chat. Sure. Dimitri, if you want, you can actually just type your question now too. So I'll address Dustin's question and then I can quickly address your question afterwards. Okay. As you guys are typing, I'm just going to go through this next example. So for B, I have 5 over root 3. I cannot have a root 3 on the bottom. So I'm going to multiply my denominator by root 3 and the numerator by root 3, like this. And then 3 times root 3 is going to give me 3. And in the numerator, I have 5 root 3. Now I'm unable to simplify root 3, so it just stays there, and that's as simple as I can get it. So Dimitri, if you want to just type your question into the chat when you have a moment, I can, oh, it's there. Sorry, I didn't scroll down far enough. So our goal here is to avoid decimals. So if I go and do root 2, it's going to give you a really long decimal that goes on forever. Whereas this here is exact. So the whole point of all of this is to stay as exact as possible. So with this answer, this highlighted root 2 over 4, there's no rounding here. It is exact. You didn't have to debate, okay, should I round up, should I round down, how many decimal places, any of that. This is a perfectly exact answer. Oh, okay, no worries. I just wanted to make sure that that was clear. Okay. Sounds like everyone's on the same page. So that is perfect. All right, let's do this last one here. So we have 6 root 2 over root 3. We cannot have a root 3 on the bottom. So we need to multiply the denominator by root 3. If I do something to the denominator, I also need to do it to the numerator as well. So that will give me 6 root 2 root 3 all over 3, like this. And now we can simplify root 2 root 3. So that will give us 6 root 6 all over 3. And then we just want to simplify the coefficients there. So 6 divided by 3 will just give us 2 root 6. And that is as simple as we can get it. So there are some practice problems for you, and I'm just going to pull this up. So all of this is in chapter 3.4. I know some people are asking me for the chapter numbers. So it's chapter 3.4, and there are some practice problems for you to do. I did put them on Classroom, but I'll go through and put them here as well. And just quickly grabbing them. So it's on page 167, numbers 1 to 3, just D, 4 to 6, B, D, and F, and then 7 to 12. So there is a lot of homework. I've mentioned this before, but if you get it and you don't do every single question, that's okay. But please make sure you try at least a few from each of those. So if you do a few from 1 to 3, a few from 4 to 6, and then go through 7 to 12, that's okay. But I just want to make sure that everybody feels really comfortable with this. If you're planning on taking a grade 12 math, this skill is essential. It's one of those skills that they just kind of assume that everybody knows how to do. So please make sure you really go through this and are comfortable with it. Just going to stop the recording.